Good morning.
Good
Good
morning,
morning,
sir.
sir.
Good morning.
Good
Good
morning, sir.
morning, sir.
Good morning, sir.
आवाज बहुत कम आ रहा है. Am I audible?
Yes, sir.
Yes, sir.
Okay. 22, 28 members have joined. Okay, we'll wait for another 1 or 2 minutes. We have you solved that yesterday's example last steps? Like I have just complete up to 7th step. I asked you to complete the further part. Any difficulty or any problem to find out that part? Anybody? Complete हुआ नहीं हुआ है?
हुआ, sir.
Yes, sir.
Any problem?
No, sir.
Okay. So any difficulty in designing low pass filter and high pass filter now? Because these are the steps we need to continue throughout the chapter for designing any kind of filter. So we need to remember all the steps. So we will just revise in 1 minute. So what are the steps for designing an FIR filter using Fourier series method? Or else you may expect this as a theory question also. So who will tell me the steps? Willingly, anybody wish to tell the steps? Ishwari is there? Ishwari Shalke.
Yes, sir.
आप बताएंगे मैडम स्टेप्स पूरा? What are the steps we are following for designing an Fourier series, for designing an filter using Fourier series method? What happened? Ishwari, are you able to speak? Or should I ask to someone else? I don't know, maybe she is having some problem. Yes, willingly, anybody want to express it? Willingly म्हटलं तर कोण बोलायला तयारच होत नाही. राहू दे म्हणायचं. Anyone from boys side? So can anyone from boys side tell me the steps? Yogesh is there? Yogesh? Yogesh? Yogesh Gangtade. See, this was the situation in the initial stage itself. I don't know what kind of seriousness they are having. So who will tell me the steps? Okay, let me ask someone else again. Ashwini Wagmode is there? Ashwini Wagmode. अश्विनी वाघमोडे. काय चाललंय तुम्ही लोक का उगा लॉग इन करून फिरायला जाताय का? So I'm going to put the absent marks for these people. योगेश, अश्विनी एंड और एक किसका नाम लिया था मैंने? ईश्वरी. Okay, who will tell me the steps now? Aboli, can you speak?
sir.
हाँ.
Yes. Step 1. Note the given frequency response HD of e power j omega of FIR filter.
Okay.
Step 2. To calculate desired impulse response using inverse Fourier transform. Formula for that is HD of n is equal to 1 by 2 pi integration limits minus pi to pi HD of e power j omega into e power j omega n into d omega.
Okay.
Step 3. Truncating HD of n to h of n for given sample of FIR filter and find the values of h of n, where h of n is equal to HD of n and magnitude of n is greater less than or equal to n minus 1 divided by 2
Okay.
or 0 otherwise.
Okay.
Step 4. Find the transfer function of filter using the equation h of z is equal to h of 0 plus summation n is equal to 1 to n minus 1 by 2 h of n into z to the power n plus z to the power minus n.
Okay.
Step 5. Convert above transfer function to realizable transfer function using h dash of z is equal to z to the power minus n minus 1 by 2 into h of z.
Okay.
Step 6. Find the filter coefficients like h of 0, h of 1, h of 2, etc.
Okay. Okay.
Step 7. Find the frequency response of given filter using h of e power j omega is equal to summation n is equal to 0 to n minus 1 by 2 a of n into cos of omega n,
Okay.
where a of 0 is equal to h of n minus 1 by 2 and a of n is equal to 2h of n minus 1 by 2 minus n.
Okay.
Step n. The magnitude in dB is calculated by varying omega 0 to pi, where
Okay.
magnitude of h of e power j omega in dB is equal to 20 log of in magnitude h of e power j omega,
Okay.
where we are varying the omega in degrees.
Okay.
The paper.
Okay. We are just plotting the table. We are drawing the table, and with that we are calculating the value of h of e power j omega and log value of, that is dp value of h of e power j omega. After that, lastly,
Plotting the graph.
we are plotting the graph. Okay, good. Now, based on this, we are moving towards the next part. Just write the title as title for the today's lecture. So, design of FIR filter using Windows. Just write the title for the today's lecture as design of FIR filter using Windows. Is my screen is visible?
Yes, sir.
Yes, sir.
Okay. Just write the title as design of FIR filter using Windows. Okay. So why to go for this Windows? That's the first question. Why to study the different Windows for designing an FIR filter. So as already we have seen some examples related to the FIR filter using the Fourier series method, that is for low pass filter as well as the high pass filter. So in that case, what we have observed is, so in the low pass case filter, we have observed the ripples are present in the pass band as well as the stop band. Wherein in high pass case filter, there also the ripples are observed in the stop band as well as the pass band again. Okay, the purpose of moving to this design of FR filter using window is to reduce the size of the ripples which are present in stop band and the pass band. So that is the main purpose. Understood? Have you got the point? Shall I repeat
Yes,
it
sir.
once again?
Yes, sir.
To reduce the ripples present in the pass band and the stop band, we are designing and filter using the window method. So there are again different windows. We have like rectangular window, triangular window, then hamming window. The different windows are there, and the separate windows are having their own advantage as well as the disadvantage also. So that is the main purpose. So the main is like as we have seen with the Gibbs phenomena technique. Gibbs phenomena में क्या हुआ था वहां पे? So why this Gibbs phenomena technique is occurring? As we know that while we are converting from time domain to frequency domain, so there is a transition, right? जैसे कि अभी आपका अगर पास बैंड टू स्टॉप बैंड सिग्नल मूव हो रहा है, थेराटिकली क्या होता है? आइडियल रहता है, right? Suddenly there will be a zero at cutoff frequency, but that is not possible with the in the case of practical application. So what is happening in the practical application? When it reaches to the cutoff frequency, slowly the signal is getting attenuated. मतलब वहां पे transition band बड़ा हो रहा है आपका. If your transition band is more, then the ripples are more present in the stop band as well as the pass band. तो हमें क्या करना है? We need to reduce the transition band. जैसे कि आपका transition band is approaching towards the ideal characteristics, then the ripples in the pass band and the stop band are reduced with the help of this window technique. I got the idea why we are studying this? Any confusion here?
No,
Can
sir.
anyone repeat what is the purpose of studying the windows?
To reduce the size of ripples present in stop band and pass band.
Okay, to reduce the size of the ripples present in the stop band and pass band. So let us see, like stepwise we will understand again how it can be reduced. Now you just start writing the step one. It is same as the procedure what we have seen. यहाँ पे सिर्फ एक step change होगा आपका, बाकी सब same रहेगा, right? You just note down the desired frequency response. The desired frequency response, HD of e power j omega, HD of e power j omega of a filter is the desired frequency response, HD of e power j omega, H should be capital here, HD of e power j omega of a filter is periodic in frequency, and can be expressed in Fourier series, which is given by write that first equation, HD of e power j omega. So here you need to remember these notations, like one in some books they are used directly HD of omega also, don't get confusion. That is HD of e power j omega, or in some book they are used it as omega also, right? So HD of e power j omega equals to n equals to minus infinity to infinity HD of n e power minus j omega n, e power minus j omega n, where HD of n equals to, you write that formula. Already we know this. HD of n equals to 1 by 2 pi integral minus pi to pi HD of e power j omega into e power j omega n d omega. What is HD of n here? What is HD of n? Anybody? HD of n is what? लिख के दिया है मैंने, and repeated steps I am telling.
Impulse response.
Impulse response, or here in this, like this is the formula of Fourier series we are writing. Okay, so here HD of n is acting like a Fourier coefficients. Just write that part. Fourier coefficients having infinite length. HD of n is as a Fourier coefficient having infinite length. Having infinite length. Next point you write. One possible way of obtaining FIR filter. One possible way of obtaining FIR filter. One possible way of obtaining FIR filter is to truncate the infinite Fourier series. To truncate the infinite Fourier series as small n equals to infinite Fourier series as small n equals to plus or minus n minus 1 by 2, plus or minus n minus 1 by 2, where capital N is the length of the desired sequence. Where capital N is the length of the desired sequence. Next point you write. Next point. Due to abrupt truncation of the Fourier series, results in oscillation or repulsive, right? Results in oscillation or repulse in pass band and stop band. Oscillations or repulse in pass band and stop band. Full stop. Pass band and stop band. Full stop. These oscillations are due to slow convergence of the Fourier series, and this effect is known as Gibbs phenomena. This effect is known as Gibbs phenomena. GIBBS. Gibbs phenomena. or this effect is known as Gibbs
Yes, sir.
phenomena. Next point you write. To reduce these oscillations, to reduce these oscillations, to reduce these oscillations, the Fourier coefficients of, to reduce these oscillations, the Fourier coefficients of the filter are, to reduce these oscillations, the Fourier coefficients, the Fourier coefficients of the filter, of the filter are modified, are modified by, modified by multiplying the infinite impulse response, by multiplying the infinite impulse response with infinite impulse response with a finite sequence, with a finite sequence omega of n, with a finite sequence omega of n, called as, called as a window, called as a window, where just write that equation. You just give the numbers. First one is equation 1, equation 2, and that omega of n you write it as equation 3. So it is 1 for magnitude n less than or equals to n minus 1 by 2, and is 0 for magnitude n greater than n minus 1 by 2. Or
Yes.
how many of you have written it as n square? कोई लिखे क्या वहां पे n square बोल के?
No, sir.
नहीं लिखे ना? लिखे? कौन है लिखने वाले n square? I'm joking. It is not n square. It is simply n minus 1 by 2 and 0 for magnitude n greater than n minus 1 by 2. Please don't write it as square. So यहाँ पे कुछ नया दिख रहा है आपको? Nothing is new. Already we have discussed these things, right? कुछ different दिख रहा है अभी यहाँ पे? What is the new thing you have observed here? Omega of n is a window function. ठीक है? तो in normal case, what we have done for the truncating? क्या किए थे हमने वहां पे? How we have written the formula of truncating? Yes?
H of n is equal to HD of n.
Okay. What we have written? Simply h of n equals to hd of n. लेकिन यहाँ पे क्या होगा अभी? That hd of n is multiplied with omega of n. So that is the difference. Rest all thing is same again. Okay. Just write the next point. Call it as equation 3. Equation 3. After that, you just write. After multiplying window sequence omega of n, after multiplying window sequence omega of n with hd of n, with hd of n, we get a finite duration sequence, we get a finite duration sequence h of n, finite duration sequence h of n that satisfies the desired magnitude response, that satisfies the desired magnitude response, So you just write this equation now, and let's call it is equation 4. This equation you need to write, and let us call it is equation 4. क्या डिफरेंस है अभी यहाँ पे? So this is what we are simply calling it as a truncating. What is the difference here? While truncating, we are just multiplying the infinite sequence into the finite sequence, that is hd of n into omega of n. So that is with the window function again. आपके यहाँ पे omega of n may be the value of rectangular window, or maybe the value of hanging window, or maybe the value of triangular window. Different types का window function है, वो function का value हमें यहाँ पे multiply करना है. Okay, call it as equation 4. And this is the only step which we are getting the change. Finished?
Yes, sir.
Next point you write. Next point, the frequency response h of e power j omega. Sorry. The frequency response h of e power j omega. The frequency response h of e power j omega of the filter can be obtained by convolving hd of e power j omega, that is capital hd of e power j omega, and omega of e power j omega, and omega of e power j omega, which is given by, just write that equation. यहाँ पे सिर्फ अपना कन्वोल्यूशन का फॉर्मूला यूज कर रहा है, right? It is like hd of e power j omega is convoluted with omega of e power j omega. The formula is x of k into h of n minus k. So likewise, the first term we are writing it is hd of e power j omega, omega e power j omega minus theta. That's it. And call it as equation 5. Any difficulty in understanding this?
No, sir.
So this is what the mathematical view we have observed now. The same thing we will observe with the graphical representation. तो पहले हमने क्या किए, एच डी ऑफ ई पावर जे ओमेगा का इक्वेशन लिखे, दैट इज द फोरियर सीरीज इक्वेशन वी आर रिटर्न. Then we have written the equation for the Fourier coefficient, that is hd of n. After that, we have done the truncation part. The truncation part, what we have done is simply h of n equals to hd of n omega of n. Before that, we have defined a window function, and then finally we have taken a convolution of the frequency responses. Now let us see graphical how it will look like. तो ये अभी what you are observing, क्या समझ में आ रहा है आपको इससे? what you are understanding with this? Anybody? Mathematical view we have looked at. This is what simply I am representing the same thing in a graphical form. क्या समझ में आ रहा है यहां से? HD of e power j omega, that is the desired frequency response in figure A, and what it is showing in the figure B, the filter coefficients. Are you getting this point? हेलो,
हाँ सर.
है क्या वहां पे? फिगर दिख रहा है आप लोगों को? इज इट विजिबल?
हाँ सर. Yes sir.
Okay, so HD of e power j omega I have taken. It is a low pass filter structure I have taken, and then I am calculating the filter coefficients. Filter coefficients को हम क्या कर रहे हैं? Like HD of n. This way we are representing it is, which is having the value from minus infinity to plus infinity. We just note down this diagram. Figure A and B. जैसे हमें 5 इक्वेशन लिखे उसके हिसाब से अभी फिगर भी प्लॉट करना है. Finished?
Yes sir.
Now, what we have written next? उसके बाद क्या किया हमने? एक विंडो फंक्शन डिफाइन किया. ठीक है, तो विंडो फंक्शन डिफाइन किया एंड देन we have noted its Fourier transform. So this here omega of n is representing like a window function which is having the value from, let us take minus kitna ye value, let's assume it is some value. We are having like 0 1 2 3 4 5 6 7, so -7 to +7 we have some function. ये आपका विंडो फंक्शन है. ठीक है, now if I take its Fourier transform it will look like this way. Getting my point? तो पहला क्या कर रहे? We are going in this way, right? So first this is our desired frequency response. After that we are calculating the Fourier coefficients. Then I have defined a window function, and after window function if I apply a Fourier transform to this, so I will get this way. That is omega of e power j omega. So here you just draw this. Hope you are all drawing the diagrams. Any difficulty in observing or any difficulty in display?
No, sir.
जो मैथमेटिकल पार्ट में लिखा हूं मैं उसका ग्राफिकल रिप्रेजेंटेशन कर रहा हूं यहाँ पे. नथिंग इज डिफरेंट, so that you can understand the graphical view of those equations also. अभी यहाँ पे आप लोगों को फोरियर सीरीज और फोरियर ट्रांसफॉर्म का इंपॉर्टेंस पता रहना चाहिए. लाइक फर्स्ट वन इज लाइक अ फोरियर सीरीज, right? So HDI of M is, we are writing a Fourier series and we are writing its coefficient. Then in the second part we are writing the Fourier transform. तो क्या difference है दोनों में? Here time domain function are in discrete nature, whereas the frequency domain functions are in continuous nature. और तो यहाँ पे जो फिगर 6C है अभी, लाइक फिगर C, होप यू आर ऑब्जर्विंग दैट. सो what kind of signal it is? Can anyone tell me? ऐसे सिग्नल कभी देखे क्या आप लोगों ने? Have observed such kind of signal? उसको एक नाम है, क्या नाम है उसका? शायद सब सिग्नल आप लोगों ने देखे हैं, कि इसको स्पेसिफिक नाम है एक, फिगर सी. व्हाट इज दैट? What is the name of figure C?
Sync function.
Yes, it is sync function. Very good, madam. Now, by looking at this signal, what we are observing here is, तो ये पहला पार्ट क्या दिखा रहा है आपको? So this one, what it is looking like? कोई बताएंगे मुझे? It's like a main lobe. हम क्या बोल रहे हैं इसको? It is a main lobe wherein all the power is going to be concentrated at this position. ठीक है? So this is our main lobe. बराबर? And these are further parts are what we are calling. कोई बताएंगे मुझे? These are the side lobes, right? Yes or no? These are the side lobes we are calling, or else simply we are calling it as a ripples which are present or which are reducing after as the frequency moving towards the value of pi again, right? So that means यहाँ पे आपका maximum power रहता है, as the frequency moves, then the signal is reducing to the zero value again. So that means the width of this main lobe is, we can call it as like minus 2 by pi n to 2 by pi n. So let me call it as simply the width of this lobe is 4 pi n, 4 pi by n it is, right? So that is what. So by using this window method, हमें क्या मिल रहा है अभी? We are what we are doing finally. Let me show you in the further part again. So I understood this importance of this sync function. Hello.
Yes, sir.
Have you understood the importance of the sync function? तो यहाँ पे इसको main lobe बोल रहे हैं हम, and here is the maximum power is going to be stored, and the value which move towards the omega value, then the size of that signal is going to reach to the zero value again. So now, if I move to the further part, this way. So what you are understanding? What is figure E? Figure E क्या है आपका अभी? How it looks like? Yes? Anybody? What is figure E?
लो पास फिल्टर.
Yes, it is a response of low pass filter. So हमने पहला एग्जांपल सॉल्व किए थे. फर्स्ट एग्जांपल वी हैव सॉल्व्ड. बराबर? यस और नो?
हाँ सर.
हाँ, तो उसका रेस्पॉन्स हमें ऐसा ही कुछ आया था. बराबर? तो वहां पे इट्स लाइक लुकिंग लाइक दिस वे. दैट इज व्हाट वी आर कॉलिंग इट एज द फ्रीक्वेंसी रेस्पॉन्स. हम क्या बोल रहे हैं यहाँ पे? इट इज the h of e power j omega is the frequency response. So this is like a frequency response of the low pass filter. Okay, now so यहाँ पे what's happening is, so ये वैल्यू क्या है आपका? h of n equals to क्या हो रहा है अभी? What is next part? We are truncating the function. तो क्या कर रहे हैं हम यहाँ पे? We are like h of n equals to h d of n into h of n. तो इसके यहां से ये रेस्पॉन्स आपको मिलेगा. राइट? गेटिंग माई पॉइंट? ड्रॉ कर रहे क्या इसको?
Yes, sir.
जस्ट नोट डाउन दिस.
Yes, sir.
समझ में आ रहा है क्या ग्राफिकल रिप्रेजेंटेशन? आप इज देयर एनी डिफिकल्टी इन अंडरस्टैंडिंग दिस? जैसे कि हमने एग्जांपल सॉल्व किया है उसी के हिसाब से मैंने आई एम जस्ट शोइंग यू द ग्राफिकल रिप्रेजेंटेशन. लेकिन अभी ये फाइनल फिल्टर कोएफिशिएंट है क्या आपके? इज दिस इज अवर एफआर फिल्टर? ये एफआर फिल्टर है क्या ये अभी? Can anyone tell me, is it a result of FIR filter? Hmm? What is the condition of FIR filter in terms of impulse response? Condition of FIR filter in terms of impulse response. What is the condition? Condition of FIR filter क्या है? In terms of impulse response, h of n is equals to anybody? यहां पे h of n की वैल्यू क्या है? Suppose if you take n equals to 25, let us assume that. तो कहां से कहां तक वैल्यू प्रेजेंट रहेंगे? हेलो?
minus 12 to plus 12.
minus 12 to plus 12. Very good. Now, whether it is an FIR filter, whether they are the FIR filter coefficients,
No.
नो, क्योंकि अगर यहाँ पे वैल्यू -12 to +12 है, whether it is causal or non causal, causal फंक्शन है या नॉन causal फंक्शन है?
Non causal.
नॉन causal है, क्योंकि यहाँ पे वैल्यू both the sides are present, the values are present on left side as well as the right side. लेकिन FIR के लिए हमें causal filter फंक्शन चाहिए, तो उसके लिए क्या करना है आपको? क्या किया हमने वहां पे? स्टेप्स थोड़ा याद करो ना. ये ट्रंकेशन के बाद क्या किया हमने? ट्रांसफर फंक्शन लिखे,
Function.
बराबर. ट्रांसफर फंक्शन में आपके पॉजिटिव वैल्यू और नेगेटिव वैल्यू दोनों आ गए, तो उसको नेगेटिव वैल्यू में कन्वर्ट करने के लिए व्हाट वी आर डन? To convert the z powers in negative powers or only in one power, that is in negative part. What we have done there? We have written the formula of realizable transfer function. What is that? H dash of z equals to z to the power minus of n minus 1 by 2 multiplied with h of z. वो करने के बाद क्या होता है? What will happen after that? The filter is going to become a causal function. तो अभी कंडीशन क्या है? It should be h of n equals to 0 for n less than 0. मतलब आपके सिर्फ सिग्नल प्रेजेंट रहना है दिस साइड, लाइक लेट अस टेक दिस वे. तो ये सिग्नल ऐसा प्रेजेंट रहेंगे अभी, ठीक है? तो ये ऐसा, लाइक दिस वे विल गेट द सिग्नल. आर गेटिंग दिस? तो इसको हम कॉजल फिल्टर बोल रहे हैं अभी, ठीक है? सो लेट अस लुक एट इनटू द लास्ट सिग्नल. तो ये ऐसा दिखता है, अंडरस्टूड? तो यहां पे वैल्यू आपका 0 to n-1 तक रहेगा फाइनली. तो अभी सो एट द फाइनल एंड, लाइक वंस इफ यू अंडरस्टैंड दिस, दिख रहा है कि एबल टू सी दिस डायग्राम?
हाँ सर.
तो यहां पे क्या दिख रहा है अभी? व्हाट यू आर ऑब्जर्विंग विद दिस? So here the simple response is present on the value that is right side. Okay, that is यहाँ पे 0 है, 0 to n-1 तक. मतलब ये मैंने जैसे ड्रॉ किया है रफ डायग्राम आपका, तो उसके हिसाब से वो सब रहेगा. जस्ट ड्रॉ दिस. So finally we will get the value so the diagram will be this way. This is our causal filter, and so here the response of the low pass filter will look like this way. So this is how the graphical representation of the equations what we have noted. Hope you understood this.
Yes sir.
Any difficulty here? Any problem, any question, any more clarification you want? Hello? Do you have any questions here? Am I audible?
Yes, sir.
Yes,
Any
sir.
questions are there?
No, sir.
है तो है बोलो, नहीं है तो no बोलो. I can move further. Okay. Now let's move to the next part. The types of rectangular window. Types of rectangular window. Sorry, types of window, not rectangular window. Next is types of windows. Types of windows. In that first one you write rectangular window. Rectangular window. I think so. What are the types here is like a rectangular window. Jenny, can you just go back to your syllabus please? वहां पे एक बार चेक करो विंडोज क्या क्या दिया हुआ है, बिकॉज मेनी विंडोज आर देयर, बट आई थिंक फॉर योर सिलेबस उन विंडोज आर वी नीड टू स्टडी. एक बार चेक करो सिलेबस में. आई थिंक रेक्टेंगुलर इज देयर, देन
Rectangular and hanging window.
रेक्टेंगुलर
Rectangular and Hamming.
दो ही है ना, ओनली टू विंडोज आर देयर.
हाँ, sir.
हाँ, sir.
Okay, so actually there are like 4 or 5 windows are there, but as per your syllabus we will go for rectangular window and the hamming or hanning. Hamming है क्या?
हाँ, sir.
Okay, just write the types of windows here are. You just write the types. You just write down, but we will study in depth only for two. Rectangular window. The second one is, at least you should know what are the different window techniques. The triangular or, just write the second one is the triangular or Bartlett window. Bartlet. The triangular or Bartlett window. Bartlet window. Then the third one is Hanning window. Hanning. Hanning window. Hanning window. Then fourth one, Hamming window. Hamming. 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 Hamming window. Next, Blackman window. Blackman. Blackman window. And lastly, we have Kaiser window. Kaiser. Kaiser window. So these are the different types of windows for designing an FR filter. But in your syllabus, only 2 windows are there. We will study in depth of those 2. What are the types you are written? Can anyone read it? What are the types of windows you are written?
Rectangular window, triangular or Bartlett window, Hamming window, Hanning window, Blackman window, Kaiser window.
Okay, so these are the main types of the windows. So by tomorrow's lecture, we will discuss about the rectangular window and the Hamming window, and then we will move further for solving the examples on that. So we'll stop it here. So if you have any questions, you can ask me. Still, we have like 1 or 2 minutes time. Otherwise, you can mark your attendance.
सर
Yes.
सिलेबस में ब्लैकमैन विंडो नहीं है, लेकिन असाइनमेंट में एक क्वेश्चन है ब्लैकमैन विंडो का.
Question है क्या? Okay. We will change that part. Anything else?
नो सर.